Okay, team, this is a second lesson in things you should probably already know about triangles. This lesson is on the Pythagorean Theorem. Make sure you can say that, Pythagorean Theorem. And the Pythagorean Theorem says, this will be familiar even if it doesn't sound familiar right now, says that the sum of the squares of each of the legs of a right triangle is equal to the square of the hypotenuse. And if you're like, well, what in the world does that mean? Let's define some terms here. So the hypotenuse is the longest side of the right triangle, and the legs are the two shorter sides. Okay. So the sum of the squares of each of the legs, each of the two shorter sides of a right triangle, is equal to the square of the hypotenuse of the longer side. How you definitely have seen this before is a squared plus b squared equals c squared. Okay, so that's what we're doing here, is we're solving now, instead of for missing angles in triangles, solving for missing sides. And it's important to note that this only applies to right triangles. Let's do some examples here. So the thing to note here, right, is which side is which. So I'm going to label my sides A, B, and C. I would suggest, as you do these, redraw a triangle on your scratch paper, just because the common mistake is not putting the hypotenuse in the right spot. Okay, so drawing it and then labeling it will help you avoid that. So what this is going to look like is 4 squared plus 6 squared, so those are my legs, equals c squared. That's what I'm trying to find, right? Okay, just simplify some. And remember, now I'm going to square root both sides to isolate c. Okay, so c equals the square root of 52. Now, unlike what we've done in previous situations where we would type this into our calculator, we want simplest radical form. Simplest radical form. So what that means is we're going to leave our square root in, and we're going to simplify it. And I know that you've done this before in previous classes. So the square root of 52, we're going to factor, right? So 52 is 4 times 13, 2 times 2. So the square root of 52 is the same as the square root of 2 times 13. And then my pairs, 2 times 2 is 4, right? Which is this perfect square. So I'm going to pull that out. Square root of 4 is 2. Okay, so 2 square root 13. Okay, so c here would be 2 square root 13. Okay, so that's what simplest radical form means. Okay, so the reason we prefer this is that it's more precise. Right, so, and some of us in the last unit ran into a bunch of decimals when dealing with square roots or roots in general, and we struggled with it, right? So if we leave the square root alone, we're less likely to run into errors caused by a bunch of repeating decimals that we have to deal with. So that's why that's useful for us to know. Okay, we'll do one more example. Here, we have 9 and 10, and I'm going to label. So notice this time, 10 is my longest side. And the longest side is always opposite the right angle, by the way. So 10 is my C. We can call 9 A or B. It doesn't really matter at that point. Okay. So I'm going to say 9 squared plus B squared equals 10 squared. Okay. And that gives me 81 plus B squared equals 100. And then I'm going to subtract 81 on both sides. And then take my square root, and square root on both sides gives me the square root of 19. 19 is a prime number, meaning it does not factor, so I cannot simplify it like I did up here. Okay, so this in this case is simplest radical form. We're done. Alright. I did put a couple of word problems in here. Here's an example of one of the types you'll see. The key to the word problems, so we're going to sketch. So sketch a triangle. Okay. And this one is actually like this is true. This is actually how they measure TVs. If you see a 26-inch TV, that's pretty small, right? But that's actually the diagonal. And then we want to know, with the width of the TV is 10 inches, how tall is the TV? So this is something we want to figure out in real life. If I have like a 72-inch TV, how tall is it? Will it fit in my house or not, right? So I'm going to draw, not a triangle here, I'm going to draw a rectangle, because that's what I know TVs look like, right? And the diagonal length, it says, is 26 inches. So the diagonal length would be from corner to corner. Like that is 26 inches. Notice we just made two triangles, right? And they're two right triangles because we know it's a rectangle, right? These are right angles. They're going to be the same. Doesn't really matter. The width of the TV is 10 inches. I'm going to put that down here, although I think that's probably the shorter side. And then I have A, B, and C. This is my hypotenuse. And I do 10 squared plus B squared equals 26 squared. And here, when I square both of those, oops, yeah, B squared equals 576. Sorry, 676. And then when I subtract 100, I get 576. And then I'm going to square root both sides. Okay, and in this case, my B is equal to 24 inches. Okay. Now, I'm imagining a 10-inch by 24-inch TV and thinking that is not quite how a TV is shaped. But you can be the judge of that for yourself. So one more time, I'm going to say it again because it's important. The key to these word problems, you get them right every time if you draw them and think carefully about what you're drawing.